Hi, welcome to the Building Performance Center. My name is Chris Clay and I'm the senior trainer here. Today's video, we're going to go over the Energy Auditor Field Guide in preparation for the Energy Auditor Field Test. The items we're going to concentrate on today are about combustion safety, and other videos will cover some of the other information on the Field Guide. Hi, we're going to go ahead and get going on our Energy Auditor Field Guide review in preparation for the Energy Auditor Field Test. We are going to start with the exterior section because that's where we find the first thing that's related to combustion safety. As we go along, it might be good for you to print out one of these so you can follow along where I'm at on here. And like I said, the first item in an exterior section is a gated item, and gated items are very important. If you don't get a gated item correct, you'll fail the entire exam no matter what you do the rest of the exam. If you do not get this one right, you will not pass the test. So the first one under the exterior section, item number 1 is candidate prepared combustible gas and CO measurements for instruments for use. So I'm going to start out here and start my ambient CO meter that I use here. It's my 4-gas monitor that monitors for confined space, but it does do ambient CO for me, and I'll have this clipped to my belt for the entire test. And I'm starting up my Combustion Analyzer also. I use this device for measuring CO in my appliances. And so all they're asking for us to do in item number 1 is to prepare these for use. And we do these outside because outside is our baseline. And then we'll take them inside. So the next section we're going to go to is the interior safety evaluation. And we are going to do items 1 and 2 in there. And both of those are gated items. So the next step will be going inside. So we made it inside, and we're going to start in on our interior safety evaluation portion of the field guide. There's 4 items on interior safety evaluation that have to do with combustion safety. It's lines 1 and 2 and lines 9 and 10. 1 and 2 are about confirming that you have a safe environment before you do your energy audit. And the 2 things we're concerned with before we do our audit is the indoor ambient CO levels and the lower explosive limit. Alright? Now line 1 asks the candidate to check the ambient CO levels and compare it to a standard. And line 2 asks the candidate to verbally confirm that the LEL is within less than 10%. All right. Now LEL is the lower explosive limit, so you can read up on that in the BPI 1200 standard. Okay, so right now we have 0 parts per million of CO. Even if I have 0, I need to let the proctor know I know where to refer to the ambient CO levels, and I have this document here that I got off the BPI website that will provide people who come here to take the test also, and this is where we refer to the actions required when you're at different levels of ambient CO. We're at 0, so there is no action, but you still need to make a statement to the proctor about that. All right. Later on, you may be working with an oven, or you might get some spillage off the water heater, and if CO shows up, you need to be able to show them you can refer to this sheet and know what needs to be done in those cases. All right. Now, the LEL is 0. On line 2 of the form, we're going to use our combustible gas leak detector to check this gas line for leaks. As I said earlier, we are only going to check a few joints to show you how to use the device, but you would be responsible for testing all the gas lines in the house. So I'll check a couple joints here. I'll run the head of the detector around each joint, taking about 1 second for an inch of travel. And if I did get an alert on my device, it would start beeping. Probably like that. And then I would use some leak detector fluid and check for bubbles, and I don't see any there. So I think we're okay with that. Even though that alerted, the bubble solution just tells us whether we have a leak or not. Okay, we're moving on to the next section of the field guide that has the any combustion safety items in it, and that's in heating, cooling, and domestic hot water equipment. We're not going to do all the lines in here. We're going to do lines 1, 2, 3, 4, 5, 10, 11, and 12. Those are the ones that are pertinent to combustion safety. Okay, we're on line 1 of heating, cooling, and domestic hot water equipment. This line asks the candidate to identify basic heating and cooling system types. In the test house here, we have a forced air heating system, and we have a ducted air conditioner. We're on line 2 of heating, cooling, and domestic hot water equipment. This asks the candidate to identify heating and cooling system operating components. On this heating system here, we have the vent or flue. We've got a gas valve here. We've got an inducer motor. Behind this door, we have an air handler. And over on the wall, we have a thermostat. Okay, on line 3, it asks the candidate to identify safety features related to the heating system. So I'm going to take a moment and zoom in so you can see closer. So hang on. Alright, we're zoomed in now. We're going to take a look at our safety features for our heating system. The first one is the high limit switch. That's in the airstream of the house air. So if it goes above 250 degrees for any reason, maybe a clogged filter or the air handler breaks down or shuts off, we'd have too much heat back there, that would turn the gas off to the furnace. The next safety feature is the pressure switch. It's hooked up to the inducer motor. If the inducer motor doesn't work, we won't be sucking the flames into the heat exchanger. That's a problem. We won't have good exhaust. So if the pressure switch senses pressure in this area, and if it doesn't sense that pressure, it'll turn the gas off. Last but not least is a rollout switch up here. So if by chance this safety wasn't working, our flames would be dancing around in here and doing things they're not supposed to do, so that would pick up that too. So we have 3 safeties. We have a high limit switch, the pressure switch, and the rollout switches on our furnace. Okay, the next line we're going to work on is line 4 of heating, cooling, and domestic hot water equipment. That asks the candidate to identify or discuss existing heating, cooling system health and safety concerns. You know, in most test houses, we're not going to have those types of concerns. So this is something where you're going to have to talk to the proctor about some items that you may have seen in the past. You know, in general, maybe some things like clogged filters could set the high limit off. We could have melted wires in here. Missing air handler doors. You know, the air handler door here we've basically got it taped on right now. Why is it taped on? Well, because we take it on and off all the time. But if that was missing, that's a big return leak in the combustion appliance zone. Excessive corrosion of the chimney, it could be an issue with a heating system. Disconnected chimneys, loose chimneys too close to combustion sources. Return leaks to the attic, return leaks to the crawl space. So all those types of things are health and safety concerns for a heating system. We're on line 5 of heating, cooling, and domestic hot water equipment. This ask the candidate to complete a visual inspection of the appliance flue system. And right now where the camera is, you can see this lower part, and you know, we're just making sure that it's connected and it looks right, you know, that it's not corroded and that it's connected securely. So down here it is. I can see from here that it looks fine as it goes through up to the attic. Well, other parts of my inspection, I'll be in the attic and I'll take a look at the flue up there, and I'll also take a look at the flue when I'm outside looking at the roof. I want to make sure there's a cap on the chimney that's not damaged at all, and that and it's not corroded too much. And then in the attic, I want to make sure that the flue system is together, connected, and that there's not a bunch of insulation against it. So we're in this section, generally you're going to deal with what's inside the combustion appliance zone, but in the other parts of the field guide, you'll be outside looking at the top of the chimney, and you'll also be in the attic in one part of this field guide process, and you can check the chimney during those times. Okay, we're on our combustion appliance zone testing portion of the Energy Auditor Field Guide, and we're going to start with line number 1. We're going to be using this combustion appliance zone here. It's a natural draft water heater, standalone natural draft water heater. So it is a category 1 chimney with a draft hood, so it's one that we will test for spillage. All right. In this closet here, we have a category 1 80% efficient furnace. It does not have a draft hood or barometric damper, so we're not going to be testing this for spillage. All right. Okay, now we want to set up the home. Line number 1 says set up the home for CAS testing, and I'm going to use my BPI sheet here that I got from BPI to give me some guidance. It's called the Combustion Appliance Safety Inspection for Prevented Appliances. And we're going to start with making sure we've got all our exhaust fans turned off and all of our appliances on standby. We also will close windows and doors to the exterior. And then we're going to position the interior doors. And we always leave doors that have return airs or exhaust fans behind them. We'll leave those doors open. But if there is not an exhaust fan or return, we'll leave that door closed to that room. Also, we're going to start with the combustion appliance room door closed, because that's what they want us to do off this sheet. That's where we'll start. And I'm going to go ahead and get that set up, and then we'll come back and set up the manometer on line 2. We're on line 2 of combustion appliance zone testing, and it asks the candidate to set up the manometer and the tubing for the manometer correctly. And what I want to read is combustion appliance zone with reference to outside. Right now I am not in the combustion appliance zone, I'm standing outside of it. And the combustion appliance zone is behind that closed door right there, the brown door. So I have a blue hose that goes into the combustion appliance zone and comes to my manometer, and then I have a green hose that goes to outside. So I will be able to read the pressure combustion appliance zone with reference to outside. Okay, we're on line 3 under combustion appliance zone testing. This is where they ask the candidate to measure the baseline differential. I'm going to go ahead and turn on the manometer and turn on the light here. Today there's no wind. And there's also it's not a very big temperature difference between inside and outside, so we don't have much to affect the baseline. Right now I'm reading about -0.2. In theory, we should be documenting that. And if you want to use the baseline function, you would basically hit baseline start. You'd wait 30 seconds to a minute. And then you would hit enter, and then you would be adjusted for baseline. Okay, we're on line 4 of combustion appliance zone testing, And that's where they ask the candidate to turn on the exhaust appliances and record the number. In this house we have a bath fan, a dryer, and a kitchen fan. So I'm going to go ahead and turn those on. I'm turning on checking the lint filter on the dryer. That looks good. I'm going to turn the dryer on, turn the bath fan on, and then close the door back up, which was the original condition they asked us to put the house in, and then I'm going to turn on the kitchen fan. Alright, now I'm looking at the number, and it looks like it's about -3.5, and again we're adjusted for baseline, so it's roughly -3. Let's see, it's still bouncing around, but we have around -3 to -3.2 pascals of pressure created by the fans. We're on line 5 of the combustion appliance zone testing. That's where they ask the candidate to check the air handler impact. We want to find out if the air handler is creating a bigger negative in the combustion appliance zone, or if it has little or no effect. So right now we're cruising around -3.2, 3.1, 3.2, 3.3. We're kind of in that zone where it's bumping around a little bit, but we kind of have a feeling what it is. Now I'm going to turn on the air handler and check the number again. Okay, the air handler has come on. And I don't know, we're in about the same thing where little or no effect caused by the air handler, alright? With the door closed to the combustion appliance zone. We're on line 6 of the combustion appliance zone testing. This is where they ask the candidate to open the interior door to the combustion appliance zone and record the reading. What we want to know is, does the door position of the combustion appliance zone have an effect on the pressure differential between the combustion appliance zone and outside? So I'm going to go ahead and change the position and see if the number gets any worse or if it gets better. Okay, that seemed to have little or no effect. Before we were at anywhere from -3.1 to -3.3, and we seem to be about the same now. We're on line 7 of the combustion appliance zone testing, and this is where we ask the candidate to identify what conditions cause the greatest depressurization. As you remember, we set the combustion appliance zone up, we tested the baseline, then we turned on all the fans, and then we turned the air handler on, and then we changed the door position. Once we turned the fans on, we got to about -3.1 to 3.4, and that didn't change once we turned the air handler on, and it didn't change when we changed the door position. So what caused the greatest depressurization in our combustion appliance zone is the exhaust fans. Okay, we're on line 8 of combustion appliance zone testing, and this is where the candidate will check one appliance for spillage under worst case conditions, and then state the time limits for spillage based upon the current version of ANSI BPI 1200. So I'm going to go ahead and do that next. Okay, I turned the water heater on. It's been running for about 1:45. I had set my timer for 2 minutes. 2 minutes is the current ANSI BPI 1200 limit for spillage for a warm vent. And now it's been 2 minutes. I'm going to go ahead and check with smoke around all sides of the draft hood. and there is no spillage, so this water heater passes the spillage test. Okay, we're going to wrap up our combustion appliance zone testing with line 10. This is where the candidate makes appropriate recommendations for the CAS according to the current version of ANSI BPI 1200. And that's recommendations that would, if this spilled, that's the recommendations you would make. You use the BPI sheet that we talked about earlier, and on table D1A on that sheet are test results and then the actions that go along with it. The title of table D1A is Action Levels for Spillage in Combustion Appliances. So earlier we determined that the greatest depressurization in this combustion appliance zone was caused by excessive exhaust, and that is one of the three choices of the test results. And if this did spill, there's an action required based upon excessive exhaust being the problem. You need to become familiar with this entire sheet, but table D1A is the one is very important to know to complete the test and complete it accurately. Okay, we've wrapped up the combustion appliance zone section of the field guide, and we're moving on to the next section called combustion safety and efficiency testing, oven and stovetop testing. We're going to start on line 1, and this is where the candidate measures the CO in the water heater flue gases. The important part about this test is taking it at the right time and also taking it in the right place. The right time is at about 5 minutes of run time, so we've reached somewhat steady state, and the right place is in the undiluted flue gases. Up here is the wrong place because the flue gases are being diluted by the draft hood. So we're going to take our test below the draft hood, and I'm getting approximately 27 parts per million air free of CO. Okay, we're on line 2, where the candidate has to apply the correct action level based on the test results for the CO and the flue of the water heater, and they need to reference the current BPI, ANSI BPI 1200 standard. There's two things you need to be familiar with in the standard here, and one of them is the CO thresholds table. It's called Table 1 in the BPI document. Table 1, CO thresholds, will let you know what level of CO is acceptable, and for water heaters on this table it's 200 parts per million air free, and we only had 27 parts per million air free in here, so we didn't reach the threshold. Also, you need to be familiar with table D1B, which is action levels for carbon monoxide. In this case, we had an acceptable level and there would be no action required, but in the cases of unacceptable, that test result is here and the action levels are, right next to it. So if you had an unacceptable level, you just read what's on the document here of what to do in that case. Again, you need to be familiar with this document for the test. We're on line 3. And this is where the candidate's required to measure CO in the heating system flue gases. Again, this is about where to take the measurement and at what time to take the measurement. We're going to run this furnace for 5 minutes, and we're going to take the CO, and we have a hole in the flue over here to take the CO measurement. This is an 80% efficient furnace, so that's the least diluted sample we can take. All right, and we're also going to take our efficiency measurement there too. I'm on line 3 here, and I'm measuring the CO and the flue gases. I have a hole in the flue here. The furnace has been running for 5 minutes plus, and I'm in the neighborhood of 180 parts per million of CO. Also, I'm looking at the efficiency, and we're at approximately 88% efficiency. Okay, we're on line 4. We just finished making our CO measurement, in the flue. We got 180 parts per million of air free. Now on line 4, the candidate needs to apply the correct action level based upon the test results from the CO measurement according to ANSI BPI 1200. So we're going to turn to our BPI sheet again. As you remember from the water heater, we need to look up the CO threshold for a furnace, and that CO threshold for a furnace is 400 parts per million air free. We only had 180, so we didn't reach the threshold. So we would say we have an acceptable level. Table D1B is all about action levels and test results for CO in the flue. And since ours is acceptable, there's no action required. Again, you need to become familiar with this BPI sheet because it has all the applicable standards for the test on it. On line 6, the candidate's required to measure heat rise on the furnace. I have a thermometer up here in the return and one here in a supply duct going to the upstairs, and I'm going to take a look at those. The reason we measure heat rise is we want to make sure that we don't have any blockage in the ductwork, or we're firing at the right rate, and heat rise is a good diagnosis of that. I find what the standard for heat rise is always on your data plate here. I looked earlier here and it's a 35 to 65 degree temperature differential that we're looking for. Take it out of my return. I've got 70 degrees out of my supply, and we have 120. So we have approximately a 50 degree temperature differential. That falls right in the ballpark of 35 to 65 degrees. So we're in good shape for temperature rise. Okay, we're on line 7, and line 7 is a gated item. And as we talked about earlier, gated items are super important. You have to get them correct. The proctor won't tell you whether you get anything right or wrong along the way, but if you don't get this one correct, you'll fail the entire exam no matter what you've done the rest of the time. So it says candidate monitored and stated ambient CO levels measured in the CAS during entire combustion safety testing. So you want to make a habit of carrying, we're going to use this 4-gas monitor here that's going to measure ambient CO for us, and it'll constantly monitor ambient CO, but you need to look at it from time to time. The combustion sheets we use in the state of Washington actually ask you to check your CO during 3 or 4 times during the test. This one is automatically having you check, on line 7 when you come across it, you'll pick this up and you'll say, I have 0 ambient CO, alright? But you also need to be able to know where to find the ambient CO levels. Occasionally you'll have CO when you're testing because of the oven, or maybe you had some spillage. So we find the ambient CO levels on our BPI sheet here on the front page. And again, there's 3 levels, 9 to 35, 36 to 69, and 70 or greater. You need to become familiar with these, because if you get any CO, ambient CO during the test, you need to be able to respond to that with these standards. Okay, we're on line 8 of our test. This is where the candidate checks the oven for items, excessive debris inside. We wouldn't want to turn an oven on and have any Tupperware or paper burn during our test. So we check inside here for any problems. There's nothing in there except what's supposed to be in there. I'll even check down in this drawer because I've had stuff down there heat up and cause problems during the test. We're on line 9, and it says candidate used appropriate sampling location for the oven test. I've had the oven running at 500 degrees for 5 minutes to reach steady state, and I'm going to take my as measured measurement at the proper sampling location, which is at the back here where I can feel the flue gases coming out, and we'll let it hold for a minute here, and it looks like it's jumping around a little bit. We have about, it looks like about 240 parts per million as measured CO. We're on line 10. This is where the candidate must apply the correct action level according to the current version of ANSI BPI 1200 for the CO in the oven. We ended up with 240 parts per million as measured. I'm going to look up what the threshold is for ovens on my BPI sheet, and it has it listed at 225 parts per million as measured. We're at 240, so we have an unacceptable level. I would find my action for unacceptable levels on table D1B, and it says that we need to advise the homeowner or occupant that the appliance should be serviced immediately by a qualified professional. I also want to pay attention to my ambient CO, and I have 0 ambient CO, which is good. But if you do have ambient CO, you need to make sure that you know where to find the action levels on this BPI sheet. It happens quite often that we get CO in these test houses during the oven test. Okay, we're on line 11, which is the last line, that last combustion safety item on the field guide, and it's about the stovetop burners. We're supposed to inspect the stovetop burners for flame quality. This is quite a subjective test, but generally what we're looking for is that the flame is complete all the way around the ring here, and that they light. All right. If the flame is missing in places, then what you have is excess carbon monoxide production, which could be an issue for the ambient CO in the house. So we'll go ahead and light these off, and that one comes up and looks, that nice blue flame, complete flame all around, looks great. We'll try the back one here, and that one looks great too. It's complete. You know, this is a stovetop in the test house here, so it doesn't get much use. Okay, let's see here. Now that one, yeah, that one looks fine. Good blue flame, complete around the ring. Same here on this one. Have a little bit of yellow there, but you know, it doesn't look like much problems. Alright, so we've completed the combustion safety testing for the Energy Auditor Field Guide, and hopefully this was helpful for you. And we'll have more videos in the future for the other parts of the Field Guide. Thanks for watching.